Hello all. I want to make a little video to show you a neat little trick for solving one of the p-set problems. You had to maximize the angle for the object being launched off the cliff, number 3. Well, there's a neat way that you can do that problem using Excel. I'm not sure how many people ever used an Excel spreadsheet, so that's something that a lot of you are going to encounter quite a bit in your lives. So I thought you'd give you a little bit of an Excel tutorial, as well as how we could use that problem, or how we could use an Excel spreadsheet in order to solve that problem. Now, hopefully you have a solution already. I have your p-sets. I'm looking at them tonight. The main thing is I need to know the equations that I'm going to work with before doing this in order to do this effectively. But once I have those equations, I can solve it pretty easily. So here I'm going to share my screen, and we can look at an Excel spreadsheet, and I can kind of talk our way through it. So desktop, share. Okay. Let's ignore all the other random stuff on my page, and here we go. So when you open up an Excel spreadsheet, and actually let me just open up a blank one here. It is a blank series of boxes. Each of the boxes is called a cell. So if you've never seen that, and the way it's organized is almost kind of like a matrix. And in fact, that's the logic which undergirds all of this. It's just a giant matrix. Every column has an identifier by a letter. Every row has an identifier by a number. And the nice thing here is that we can put in data, say like 2, 4, 5, whatever. But what I can also do is then manipulate that data. I can come over to the next column, and let's say I want to double everything in that previous column. I can say, well, 2 times, and then click on that cell, and boom, I get 4. And then I can do that for the entire row, or the entire column of data by, so you get a little crosshatch there, dragging it down, and there you go. And it just multiplied everything by 2. But we can do a lot more complex things than just multiplying data by 2. In fact, Excel has so much functionality in terms of the types of things we can do. Like, for example, summing up rows. I can just use what's called the sum operator and just say sum up all these things. And there you go. And there you get 54. And has a lot of flexibility as long as you know how to program it. You'll notice here that if I go into a cell and I click the equal sign and start typing, I get this list of all these different functions that I can use. And there's so many of them, and they do many magical things depending on what you need. And I'm just going to focus on a couple of them here today. But let's just go away from this generic and back to our problem. So what we were asked to do is maximize the range for angles. So what I can do here is write a little script that allows us to calculate the range at a given angle. And so I've already got things set up a little bit here. You'll notice I have a little thing that says initial velocity. So I'm going to be able to type that in. So cell B1 is going to be where I can put in my initial velocities, initial heights. That was 2000. So I'm going to type that in. And the acceleration we know is negative 9.8, but I can make all of those variables, right? Angle. So I'm just going to put in angles here, and I'll show you what we're going to do with that a little bit later in terms of how we're going to fill it in. But let's say 0, 1, 2, 3 for the moment. But by the way, once I put in a couple of values, if I highlight them and then grab on the bottom right-hand corner there and just drag, it can kind of do pattern recognition. And there you go. There's other ways to do fill. I can fill in a column by using the fill function as well, and it'll fill in a whole bunch of values that way. I'm going to keep it fairly simple for this first maybe foray into Excel. Anywho, here we go. I'm going to do this problem. You'll notice over here I have some equations. I'll talk about them in a second. Actually, let me write in the next one. There we go. Just so that we can see what all of our equations are. So here are angles. These are angles in degrees. Now, when Excel calculates things like sines and cosines, it uses radians. So I need to convert from degrees to radians. So let's do that conversion. I know, so to do an equation, I'm going to do 0. And what I want to do is multiply this angle by, as we know, pi over 180 is the way of doing that. So times pi. Now notice here, pi is actually a function so that I don't have to, put in 3.14. It'll give me all the values of pi and divide it by 180. And there you go, 0. And just to show you that that's working, okay, there you get it. And those are the values in radians. And so then sine, I'm going to do the sine function, 0, sine, and you notice sine pops up. I click on it, and I just have to say sign of number, and I want to make that sign of whatever is in this cell there. Boom. Now, you'll notice that when I drag this down, in the underlying function, it was B7. If I go to the next row, it's B8. When you drag boxes down, what it does is it changes the row identifier. If I were to actually drag that box across, it wouldn't change the row identifier. It would change the column identificator, which identificator, that's not a word, but you know what I mean. Identification. So there's a lot of interesting things I can do with that. So let's do cosine of, and once again here, boom. And those, I always like to do that just to sense check my work that I'm getting values that I know are right. We'll be able to drag those down later and do more there. I just wanted to give a sense of this. So then VIX. So what do I want to do here? I want to do VI times cosine. So VI is this B1 times the cosine value. Boom. Now, here's the thing, though. If I drag this down, I get, what's this 1,999? It's because if you looked at that, when I dragged down, not only did it change the D7 to D8, and unfortunately changed the B1 to B2, and there you go. I didn't want to do that, so I'm going to delete that, come back to the function, and if I know I'm dragging things, but I want some cell to remain static, a referent to remain static, very simply, I go back to the referent. If I put a $sign in front of the B and in front of the 1, when I drag this down, that identifier, if you look there, it's always B1 then. I can actually hold the column static or hold the row static individually by just putting the $sign in front of the B or the 1. Just for redundancy's sake, I like to do both. If I know it's that column is never going, or that cell is never going to change. So I'm going to do the same here. So VI times, and I want to do the sign, boom, come back up all through the equation by holding the static, boom, there you go. All right, and that's what I've got. Now, the time function is a little bit more annoying because what you have to do is, that is the quadratic equation that we used here. We know we're shooting up from some initial y initial. We're coming down to the ground level. I made the origin at the ground level, plus VIT plus 1/2 AT squared. And then I solved that using the quadratic equation. That's what this disaster is, but just so that we can see it. I might want to do some of these things, separately, because it is a bit of a mess, like maybe calculate the discriminant first, just so that I can do that. So I just drag that over. Maybe I'll do the discriminant first, just so we can see it. And so we know the discriminant is B squared of that expression. So if you look in that expression, the B in that expression is going to be VIY. So let's do that. Let's go VIY squared, so caret 2, okay? And then it's going to be minus 4A, and I know A here is, from the equation, is 1/2 the acceleration, so that's 0.5 times, and the acceleration is the thing here in this box. So I just click on that box, and I'm going to keep that reference solid, okay? And then that's minus 4A, and then C. What's in the C thing? Well, in the C thing is going to just be our YI. So I'm just going to put that in there, and I'm going to hold that reference solid as well. Great. And then I'm going to close parens on that because it likes my close parens. Okay. What did I do there? All right. So B squared minus 4AC, and that's what I'm getting for the value of my discriminant. Let's just check the equation then. F7, which is VIY squared minus 4 times 0.5 times the acceleration, which is right, times the initial height. Now, notice here, if I change the initial height to say 1,000, that changes right away in real time there. So I can play with that then, and I can just drag that down. So I know I'm going to take the square root of that discriminant. So there we go, square root discrim. So I'm just going to do that and then raise that to the 0.5 power. Boom, that's what I've got there. And now I probably feel comfortable with my time. So here's the thing. I know I've got that plus or minus there. So let's think through what we have here. I have a minus VIY, right? Let's actually just calculate it with both the plus and the minus. So this is with the plus. This is, whoops. Sorry, they don't like the plus sign. This is with the plus. This is with the minus. And you just code that. So now what we're going to do is negative VIY, right? So negative VIY, because that's what the quadratic equation tells me to do. And this is going to be plus the square root of the discriminant. Okay, so that's what the numerator is, all over 2a. So divided by 2, and the a in that expression is 1/2 of the acceleration. So I'll just get rid of the 2. So I'm just dividing by the acceleration then, and I want to hold that referent constant. Okay, and I get that. And that doesn't make any sense. So that's a negative time. Oh, so this plus is not going to mean anything. So here we go. Let's do the same thing, but with the minus. So it's equal to negative VIY minus square root of the discriminant. Put all that in parens, all over the acceleration, and hold that reference constant. Boom, and I'm getting that as my time. Okay, and so those are the times that go with the minus one, and that's fine. That's what I'm going to want. So I'm actually just going to delete this column because we're going to see that it is not useful in terms of our analysis, and I'm just going to click delete and get rid of it. All right, cool. So those are our times that we get with minus. So now I'm just going to label that as my time. Now notice here, as the angles increase, so does the time. That should make sense, right? Because you get your maximum time when you fire something directly upwards. So I'm just going to extend all of this down, right? 60, and you can see the time is increasing as I increase. And we only want that to go to 90, right? So there's my time if I shoot it straight up. So then range. How am I going to do the range? Well, the range is just equal to VIX times the time. So there we go, VIX times my time. Okay. And that's what I've got. Now, here's the interesting thing. We know that as angle increases, VIX decreases and time increases. There's going to be somewhere where we get that maximum. So I'm just going to fill in this entire column up to 90. And there we go. Let's look for it. Now, this should make sense, folks. When we fire at 90, notice that number, that's some number to the negative 10 to the negative 13th. That's virtually 0, right? There's just rounding stuff going on there. Eventually, Excel doesn't go out to infinite number of decimal places. That's just silly. So that's functionally 0. So that should make sense. But if I look up here, I can see that, actually, let's start with 0 and go down. The numbers are still growing. The numbers are still growing. The numbers are still growing. 2244, 2250, 2254, 2258, 2260, 2262. Okay. And you'll notice I hit a peak at about 24, but I don't know exactly where the peak is. I know it's somewhere between 23 and 25. Okay. But what I can do here is I can come in here and get more granular with this. So what I'm going to do here is, well, maybe if I just come in here and insert a whole bunch of rows, I only wanted to really do 10, I do 23.1, 23.2, and you can just see it's just filling it in, 23.3, and I can stop typing now because what I can do is just extend the formula down to 23.9, right? And extend these formulas down as well. You can see what's going on there, and we can investigate if that's where my maximum is, because we know that this was 2263.33, and you can see that no, the max was happening somewhere after 23. It's happening at 24 something. So let's investigate that. Pull those values down a little bit. So one thing I can do is, rather than inserting, I can just pull down a whole bunch of values and create some space there. There's more artful ways to do this, by the way, but this is a particular way I could do it. 24. I'll just type them. Why? By the time I drag and drop, I will have done this. It's not that many things to type. Okay, and I'm just going to get rid of these. There you go. Let's see if it's happening somewhere in there. 23.3. Oh, here we go. That's where my inversion is happening, right here. Okay, where I have 24.3 degrees seems to be where my maximum value is. And now I could go more granular. I can go 24.33 and do like down to the hundredths place. But let's be honest, angles to those degrees are not important. And by the way, let me just click off share screen for a second. Here's my solution, which you will receive. But the important thing that I do want to show you is, what is that result that you see at the end? It's 24.3 degrees. So just through an algebraic solution, I'm getting the same thing as our spreadsheet solution. So spreadsheet solution is a really nice way, if you need to test a whole bunch of values, to code something that allows you to run through those values without analytically figuring out something. Oftentimes in science, when we have big batches of data and we want to investigate what small changes will do, we would create a program, because let me go back to sharing my screen again. The nice thing about this program, the way I have it set up, is I can come back here and say, well, what happens if I fired it off at 200 meters per second and all the numbers changed? And you're going to see that maximum launch, or that maximum angle is still getting bigger here, but it peaks somewhere around, here we go, about 35 degrees, still less than 45. In fact, as long as I'm firing something from a cliff down to a valley, no matter what, that maximum angle of launch has to be less than 45. And I want you to think about why. That's the important piece, right? So this is a nice way of checking our work to make sure that what we thought was true gels out when we look at all the data. This is also a solution to a problem. If you're just asked to find, you just need to narrate a solution as to why a spreadsheet is a good way of doing that problem, and then explaining each cell of coding, right? In the same way that I explained all of these cells, you would want to explain what each of your cells are if you were going to try and submit that for solution. So hopefully you learned a little bit about Excel spreadsheets and their power in examining large swaths of data in order to look for patterns. So with that, there we go. Figure out how to stop the recording. There it is.